So we have seen the real numbers a and b. The transformation, the one that we just did, was 3 and 4i, right? Or here, 3, we multiply by 3 plus 4i. And then what happened? It got rotated and stretched by 5. So now, if you remember what we did from here, the scale factor was what? The r, which was square root of a squared plus b squared, right? So here, they're going to give you a different equation, but let's see if it is the same thing. So again, what we've done is a plus bi is the transformation, and we multiply by x plus yi. Let's see if this is the same thing. So what can we do? Let's FOIL. Yeah, distribute it. So a times x, ax. A times yi is positive ayi. Bi times x is bxi. And bi times yi is byi squared. What was I squared again? Root negative 1 squared, which becomes negative 1. So here we have I squared, so that becomes what? By times negative 1, which is negative by, right? So let's put the x's and y's together. So it is ax, and this became what? Negative by, right? So put negative by, and let's put the i's together. So here, plus ayi and bxi. So here, I have ax minus by, plus here we have i's in common, right? So let's take out I. And just like here, let's put the x's first. So I will put bx first. And then I'll put ay. And i's been taken out. So is that what they ask you to verify? That they are true? You see, ax minus by plus bx plus ay times I is same as a plus bi transform applied to your complex numbers, okay? So now let's go ahead and write this in order pair form, matrix, and there's no vectors. So here, so if you look at this as x and y for polar, what is x? Ax minus by is the real number portion. What is the imaginary number portion? Bx plus ay, right? This is your x and y in a rectangular form. So now if you write in a matrix, how can you write it? This is ax minus by, and y is bx plus ay. And if you want to write it in two separate product of matrix, you can do what? This is a, but here's x. It will multiply. So it's a and negative b. And here b and a. You see, when you sandwich x and y, right, it goes here, x and y, and it becomes ax minus by, bx, ay. It's the same form. So what we are doing is, when you multiply a plus bi transformation, it is same thing as multiplying by this matrix. AA, B, negative B. Okay? So here, if you have A, B, C, D as a transform and has the geometry effects of rotation and dilation, then what do you know about the value of A, B, C, D? Again, it should have A, these two are the same, and these two are opposite, right? So that means these two must be the same, and these two must be opposite. Okay? That's just a different way of transforming using the matrix. Okay? So now, again, discard the form matrix ABCD so that transformation has geometric effect of only dilation by a scale factor R. It didn't rotate. That means what? And it only dilated by scale factor of R means what? R equals to square root of A squared plus B squared. And R tangent of B over A must be what? 0. It did not rotate. So how would your matrix will look like? We have to solve for A and B. So let's look at this first. How do you undo inverse tangent? You can take tangent on both sides. So B over A equals to tangent of 0. What's tangent of 0 on the unit circle? What's tangent of 0? 0, right? Y over x, 0 over 1. Sine is 0, x cosine is 1, is 0. If B over A is 0, which value can be determined? B is 0. So B is, remember, it must be A, B, B. It is 0, 0. Negative B is still 0. So now we just got to find our A. What would A be? So if B squared is added to A squared, B we know is 0, then this becomes 0. So square root of A squared is R. So square root of A squared is A. So what is A? R. R. So R and R. So if there's just a dilation by scale factor of R, this is how you'll write it. So let's say the unit square got dilated by 2, no rotations, then it will look like 2, 0, 0, 2. If it was scale factor by 10, it will look like 10, 0, 0, 10. Okay, the 2 by 2 matrix that you're going to apply to make the transformation. What about B? Here, now, there is just rotation of theta, no dilation. What if it just rotated theta degrees? So R equals to square root of A squared plus B squared again. Right? What should R be? If there's no dilation, it should be 1, not 0, right? So 1 equals to square root of A squared plus B squared. So I cannot figure out what A and B are. What about theta? Arc tangent of B over A, always, right? Y over X was equal to the angle, which they said is theta. So let's see what that gives us. So how do you undo arc tangent, inverse tangent? You take tangent on both sides, right? So now, B over A. So now, B over A is what? Tangent of theta. What's tangent of theta in a fraction or quotient? Sine of theta over cosine of theta. And our R is just 1, right? So then what is your B? Sine of theta times R. R sine theta is your Y, but R is 1. Didn't stretch. What is A? Cosine of theta. So then how do you write it? It was A cosine theta, cosine theta. Remember, it's AA. This is B sine theta. And this becomes negative sine theta.
So why is the B negative? I thought the C.
Oh, no. When we did this, it always becomes AAB negative B. The one on the top becomes negative. Okay? So this is the 2 by 2 matrix transformation. If there's no scale factor, if there's no dilation, but just a rotation. Yes? Yes. But if there's a scale factor, if it's dilated and rotated, so here, if it rotates by theta and dilated by scale factor of R, then it becomes what? Cosine theta, cosine theta. And was it sine here? Sine theta, and this was negative. But now, yeah, it will be multiplied by R in front of it. So it's R, 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 R.